Welcome everyone to Wes Explains Best. We haven't done this in a while, but this is from the mailbag. We had an assignment on Khan Academy, which was multi-step system of equations within word problems. So word problems that are system of equations oriented, and we're having a lot of issues with that. And this particular problem was in this Khan Academy, so let's go ahead and do that. Sakura speaks 150 words per minute on average in Hungarian and 190 words per minute on average in Polish. She once gave cooking instructions in Hungarian, followed by cleaning instructions in Polish. Sakura spent 5 minutes total giving both instructions and spoke 270 more words in Polish than in Hungarian. How long did Sakura speak in Hungarian and how long did she speak in Polish? This is what we need to do with this problem. The first thing you always do in system of equations is you want to define your variables. And it's very clear here. We want number of minutes in Hungarian, and we want the number of minutes in Polish. So let's go ahead and establish those as our two variables. So we have H, we'll make that total minutes in Hungarian. And then P will be equal to total minutes in Polish. If you do not establish your variables first, you're going to be confused. You're going to be mixing up stuff. Are you talking about words? Are you talking about words per minute? Are you talking about minutes? It'll be very confusing. So make sure you always establish your variables first. Now, because this is two variables, or because there are two variables, we know we need two equations in order to tackle this. So our first equation, what can we do to figure out our first equation? Well, it always gives you enough clues for these types of problems to figure out your two equations. So we see here, Sakura spent 5 minutes total giving both instructions. That is going to be enough for our first equation. Well, how do we know? Well, we know that H plus P is going to be equal to 5 minutes. If we take the number of minutes in Hungarian plus the number of minutes in Polish, together they equal 5 minutes. So that's why it's important to make sure we label the minutes here so that we understand what we're trying to find. So we have one equation, but because we have two variables, we cannot solve for it, so we need a second equation. All right, so now that you got that, again, pause at any time. Going kind of quick here, but hopefully you guys can keep following. Now we have Sakura speaks 150 words per minute on average in Hungarian and 190 per minute on average in Polish. Okay, this is kind of the trickier part because these are clues. We have words per minute. We were talking about minutes. Now we're talking about words per minute. And then the other clue is spoke 270 more words. Not words per minute, not minutes. We're talking about total number of words. So if we're talking about total words, now we're talking about something else entirely. So how do we calculate the total words given the number of minutes that we speak Hungarian and the rate, the number of words per minute? Well, it's the same way that you figure out how many miles you drive based on the miles per hour. So if you go a certain number of miles per hour, you multiply by the number of hours to find how many miles that you go, okay? If you have a rate, that's what anything with the word per in, so words per minute, these are rates. Okay, that's at which something is done per unit of time. So rate times the time will be equal to the units, whether it's words, whether it's miles, okay? So in the same light, if we take words and we multiply by the minutes, this is words per minute, and we multiply that by the minute, we'll get the total number of words. You do this a lot in chemistry with like canceling units. So if you have minutes divided by minutes, it cancels out. That's another way to think of it. But just think here, if we multiply words over minutes times the minutes, we're just going to be left with the total, which is words. So the same thing also applies here. If we have a 150 words per minute in Hungarian, we multiply it by the number of minutes in Hungarian, H, that's where this came from, 150 times H, and that equals the total words in Hungarian. Total words in Hungarian. Same thing goes for Polish. if we have 190 and we multiply it by the number of minutes we speak Polish, that's going to be equal to, this is bothering me, got to change this. This is too big. There we go. Okay. We multiply it by the number of words per minute times the number of minutes. That will give us the total words in Polish. Okay, so we have total words in Polish is equal to 190 times P. Now, what do we know? We know that the total number of Polish words, that's this, 190p, that's the total number of Polish words, is equal to the number of Hungarian words, but it's more than that. It's not just the number of Hungarian words. It's 270 more than the Hungarian words. So how do we account for 270 more than that? Well, we have to add 270 to the Hungarian words in order to equal the number of Polish words. Okay, so that's the trickiest part, is all this. This is the tricky part of this problem. But if you can understand that rate, okay, it's derived from R, rate equals distance over time, or your units over time. So if we multiply rate times time, we get the distance. It's the same thing with words per minute. I just wanted to show kind of a background of where I got that information from. So now we have just the algebra now. Just system of equations. We have h plus p equals 5, and then 190p equals 150, h plus 270. What I would do here is I would solve for h, get h by itself, and then plug it in for p. So in order to solve for h, what I need to do is I need to subtract p from both sides. So I have h equals 5 minus p. I'm going to change that to, I don't know why I made it red. Let's leave it in green. Pardon me. Now what am I going to do? Well, I'm going to take this 5 minus p, and I'm going to plug it in for the value of h. I'm just going to rewrite this equation. Actually, I'm going to copy paste this to make it go quicker. But if you want, go ahead and rewrite this equation. The only difference is I'm going to stretch this out a little bit. I'm not going to write h. Oops, sorry. It took me a little bit. I'm not going to write h. I'm going to write 5 minus p. 5 minus p. Okay, now I'm ready to proceed. Why? Because I have everything in one variable. I only have the letter p, and that is how you solve for multi-step equations. You have everything in one variable. Okay. Now, let's proceed. The first thing I'm going to do is I'm going to distribute, what color? I'll use orange. Distribute. So I have 150 times 5. I get 750 minus 150p plus 270 equals 190p. Okay, I like to get my p's together, so I move the smaller one. I move 150 to both sides. We'll add 150 to both sides. 150 plus 190, and I get 340p equals 750 plus 270. Well, now I just do 750 plus 270. That's on the same side there, and I get 1020 equals 340p. Okay, so now I do 1020 divided by 340 divided by 340, divided by the 340, and I get p equals 3. Let's put it in the context of the problem. What did we just find here? Well, we just found the number of minutes speaking Polish, not the total words in Polish, the number of minutes speaking Polish. We found our first step. Okay, so we can go ahead and write in here, we know that the number of minutes speaking Polish was 3. And now finding the Hungarian words is very simple, because we have the equation. This first equation is, we can plug it into either one, but the first one's an obvious choice, equals 5 plus h. So something plus 3 equals 5. We subtract 3. Okay, clearly h equals 2. So we have 2 minutes on Hungarian, 3 minutes in Polish. So this was a screenshot that was sent from our mailbag. Hope you all found this helpful and that you enjoyed the video, hopefully. And I'll see you next time on Wes Explains Best. Anytime you want to see more of this, send me a message, and leave a comment, and I'll do a problem for you. Hope to see you next time.